In this problem, we're going to be using a calculator. Mainly, we're going to be using a calculator to graph and come up with some x-intercepts. So the part A is forcing us into using the second derivative test. I don't use the second derivative test usually. I can get it done without having to do that. But this one's forcing us into doing it. So I'm going to start with letter A. And we have a function, natural log x plus sine x. And because I'm being forced into the second derivative, I'm going to go ahead and find the first two derivatives. So the first derivative is going to be, well, the derivative of natural log is 1 over x. And the derivative of sine is cosine. Okay, and the second derivative, well, this is the same as x to the negative 1. So I bring the negative 1 down as the coefficient. And then if I reduce the negative 1, it becomes negative 2. And the negative puts it in the denominator, so it's x squared down there. Derivative of cosine is negative sine. Okay, this is asking for the relative extrema. So I'm not going to worry about figuring out the values of the endpoints because it wants the ones that actually fall on the interior part of the graph. So I really just need to go and graph my second derivative and find out my critical points or my x-intercepts. So that's what I'm going to do right now. So I'm graphing 1 over x plus cosine of x. So I need a new document. I don't want that saved. I want to graph. And I want to graph 1 over x plus cosine x. And graph that. And really, it only wanted us to look at 0 to 2 pi. So it's important that we don't do all of the other points, that we only look at the relative extrema during 0 to 2 pi. So I'm going to go Menu, Window, Window Settings, and I'm going to go 0 to 2 pi. And there we go. And it looks like we have two x-intercepts, so I'm going to go use my calculator to find those. So Menu, Analyze Graph, 0, lower bound, upper bound. And I do it again. Menu, Analyze Graph, 0, lower bound, upper bound. So there's my two values, 2.07 and 4.49. So I'm going to take my second derivative, because it's forcing us into the second derivative test. So the second derivative at, the first one was 2.04. If I type that into the second derivative and hit enter, I end up getting, I don't really care what the value is, I just care about whether it's positive or negative. And I end up getting a negative number. Negative means that this graph at that point would be concave down. So concave down indicates that we have a maximum. So our information is that we have a maximum at x equals 2.04. Okay, if I take the second derivative and I put in my second value, which was 4.49, and to get an answer for that, you'll find out that it is actually a positive number. Again, I don't care about the value, I just want to know that it's positive or negative. Positive means that we actually have a concave up function. So that means we have a minimum. So that means we have a minimum at x equals 4.49. And that's what it asked for, was those two x values. Okay? Second derivative to test to find the x coordinates. So we have a maximum at x equals that, and we have a minimum at x equals that. Okay, part B uses a totally new function. So we'll even change colors for you. So part B, we are looking at f of x equals x plus sine of x squared. Now, this one is not forcing me into the second derivative, so I'm not going to use the second derivative. What I am going to do is I have to find the global extrema, so I know one of the points I need to do is 0. Global means absolute, means I just got to find all of them, right? The absolute highest value and the absolute lowest value. So I have to check my endpoints as well. So I'm going to check when the original function equals 0. So the original function equals 0 is 0. And I'm also going to check when the original function equals, is pi. When my original function equals pi. And if I put pi in here, I have pi plus the sine of pi squared. If I type that all in the calculator, I get 2.71. And I left space in between because I'm sure there's some maximums and minimums that I have to take into consideration. So what I'm going to do is I'm going to find the first derivative. Well, the first derivative of x is just 1. And the first derivative of sine is cosine, but this thing is the chain rule, so I'm going to put an x squared here, but I need the derivative of that, x squared. So the derivative of x squared is 2x, so it's actually 2x times the cosine of x squared. So there's my first derivative. That's the function I like to graph and find the x-intercepts. So I've got 1 plus 2x cosine x squared. I'm going to have to show you something special about putting this in the calculator. So let's look at a new document. Don't save it. And a graph. Okay, so when I'm typing this in the calculator, I'll get to this point, and this causes me problem every time, and I've used this calculator for years. So I need you to be extra special careful if something doesn't show up right on your screen. So if I put it in the way I think I should, 1 plus 2x, go over here to trig and get my cosine, right, of x squared. That's the way I think I should put it in. That seems to look right. But when I hit enter, I got nothing. The reason you've got nothing is because this calculator saw your x that's right here in front of the cosine as a alphabetical letter. It didn't see it as a variable. It does not see this x the same as that x. So what you actually have to do is you have to put a multiplication symbol in between that. And once we do, you'll see a much different graph. All right. I also want to set my window because I really only care about the points that fall between 0 and pi. So 0 and pi. Okay, and I want my x-intercepts. So menu, analyze graph, the 0, lower upper, menu, analyze graph, 0, lower upper, and menu, analyze graph, 0, lower upper. I got 3 points here, okay? I got 1.39, 2.12, and 2.83. Those are the other 3 numbers I'm going to check. So 1.39, I'm going to find out what f of 1.39 is. I'm going to find out what f of 2.12 is. That's a 2 up there in the beginning. 2. Okay. And I'm going to find out what f of 2.83 is. And just by looking at these values of what f is, I can tell you what the absolute highest number is and what the absolute lowest number is. I don't need to go to the second derivative to do that. So if I take these numbers and I actually substitute them into my original function using my calculator, I will get 2.33 for that one. I'll get 1.14 for this one, and 3.82 for this one. So now tell me, what is the minimum, the global minimum, the absolute minimum of this function? Well, what is the smallest value that we just found? Oh my God, I just want to erase something. Can I please just erase something? All right, the smallest value is this one right here. That's our minimum. And what is our absolute largest value? There's your largest. That's your maximum. That's not so hard. Like I said, there's a lot of times I don't go to the second derivative test because I don't have to. Okay? All right, one more example after this, promise.